Hi guys, today we are shaking it up. We're going to solve for mass and acceleration with a given force values. So yesterday you learned how to calculate or solve for force. It's very simple. We just use formula. But today we are going to provide you with some more detail to calculate. So here we have the force equals mass times acceleration formula. Okay, and we also have the formula to solve for acceleration and a formula to solve for mass. Now, we can just use the force equals mass times acceleration formula to solve for acceleration and mass. How is that so? Well, let's open it up here. So we had our typical force equals mass times acceleration. And say that we, why is it there? Okay, cool. And say that we have like values for them, right? So say that we have, hypothetically, we have a force of, we have a force of like 24, right? Don't use the units yet, we do it at the end. And we also have a mass of 12, but we don't know the acceleration. So this is how it looks like. And I'm going to use A for acceleration. So here I can put it, just so you know, A equals acceleration. That is the variable I'm choosing to use. Okay. You could write it that way. You can also write it this way. I like it this. I like it this way. You can also do it this way if that feels better for you. It's up to you. It all means the same thing. Okay. So and that is the force equals mass times acceleration formula, but we do not know the acceleration. We know the force, we know the mass. So how can we determine the acceleration? Easy. This is a one-step equation, which you all know how to do. You solve by getting rid of this 12. Go away. By getting rid of this 12 and getting the acceleration variable, variable by itself. So to do that, right here, we're multiplying. So to get rid of the multiplication, we actually divide. So if we were to divide, here I'll do this, if we were to divide by 12, because we divide by 12, and which gives us a value, 12 divided by 12 is 1. So that would be 1 times A, which is just A in itself. So that would give us A. And the same thing we do on one side, we do on the other. So 24 divided by 12, that is actually 2. So is this it? Is acceleration 2? Yes, and we did not use a unit, so we don't know what we're talking about here. So make sure that you use a unit, mass divided by meters per second squared. Okay, and we'll talk about the square thing later, but it is meters per second squared is the actual one, which is correct because it mentions our units. So we give you the equation to use, like break this down. We give you this guy, like acceleration equals force over mass, and mass equals force over acceleration. It's the same thing. You're just trying to like cross out those, like cancel out those values, distribute them, and solve for your problem. Okay, but this is actually going to be given to you, and it's in your reference sheet, and you can use this, but you do also need to know, like, oh, how does this work? Why? Cool. Let's go ahead and solve for force here. You know, this is just like a quick review. So using that formula, force equals mass times acceleration, you can write this down. I'm just going to write out the first letters. Force equals mass times acceleration. We identify the mass and the acceleration. And now let's plug in those values to the formula. So we don't know the force, but we do know the mass, which is 10, and we do know the acceleration, which is 2. So we get 20. Is it 20? Yes, and at the unit, because you need to use a correct unit, the unit for a force is newtons. If you forget that, it's also in your reference sheet. Okay. Now, this is where we get something tricky. We know the acceleration and we know the force, but we do not know the mass. So whenever we don't know something, we are searching for it. So it's mass equals. We have to figure out what it is. Okay, since we're searching for mass, we use the mass formula, our equation. So mass equals force divided by acceleration. I'll do force over A. And then let's go ahead and plug the values into the formula. So mass equals force, which is 20. Okay, 20 divided by 10. So 20 divided by 10 is 2. Okay. 2, is it 2 newtons? No. The unit for mass is going to be kilograms here. And it also tells you right here. Okay. See, that's super easy. You're just using these formulas and you're bringing them in together. All right, now for acceleration. Same thing. We know the mass, we know the force, but we are missing the acceleration. We do not know the acceleration, but we do know that acceleration equals force over mass. So I'll do F divided by M here. Now let's go ahead and plug in the values. For this table, you don't need to circle the values because it just gives you 2 values, so it's really easy. But for the word problems, you do. So force, which is 60 newtons, okay, 60, divided by the mass, which is 20 here. So 60 divided by 20, 2, 4, 6, it is 3. 3 what? I hope you all said it. 3 meters per second. Per second squared. Okay, cool, awesome. Make sure to either highlight or box your values, box if you're in person, or highlight the values if you're virtual, just so it's easier for us as teachers to identify your answer. Now, moving on to this next one. This is where we're actually like circling the mass, acceleration, force values. Okay. What is the mass of a falling rock if it produces a force of 150 newtons? The gravity is accelerating at the usual 9.8 meters per second squared. Okay, I'm going to put it close together. So it's asking us what is the mass. So we don't know the mass. Since we don't know the mass, we know that we're going to use the mass equals force divided by acceleration formula. Cool. But we do know the values for force, which is this guy. And I'm going to highlight force in yellow. And we do know the value for acceleration, which is 9.8 meters per second square. I'm going to highlight that in a purple. So if you're in person, I would like for you to identify this as force, and I would like you to identify this as acceleration by putting like an A and putting like an F here, just in case you get confused with the units. You're dealing with multiple numbers here. Something that I did not mention before is that 9.8 meters per second squared is the gravitational pull if we are on Earth. If you're on another planet, it's different, so we'll go ahead and give you that later. All right, so if something always falls, it's always going to be at 9.8 meters per second. So now let's work it out. We have the mass equals force value, which is 150 in my yellow. Yeah, I'm going to do this. Maybe this is fun. 150 divided by 9.8. Okay, and now go ahead and work that out. Maybe I'll just write it up here. Now go ahead and work that out. You can type it in the calculator. I am, just to make sure I don't tell you the wrong thing. 150 divided by 9.8 gives us, okay, it gives us like 15.306, blah, 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 blah. But for here, you can just round it to the nearest tenths place. Okay, just 1 after the decimal, so it's 15.3. I don't want that. Oh, go away. Okay, well, anyway, it's going to equal 15.3. And the unit for mass is kilograms. Okay, so the unit for mass is kilograms, so making sure that you put the right unit. You get it correctly if you put the correct value or amount, and then if you put the correct unit. If you get one of them wrong, then it's a half a point off. Cool. So you're going to do that for the rest of the class today. It's you calculating acceleration and all this good stuff, and you're going to have this here. It's rather simple, but you're just going to keep practicing it because for some of us, it's not that simple. So we just really need that repetition. All right, guys, good luck.